Artificial intelligence, AI. You hear this term everywhere, right? It's in our news feeds, our phones, even our cars. But for all that buzz, what it actually is can feel, well, pretty confusing. So today, we're going to cut through all that noise and get a real handle on what we're talking about when we talk about AI.
You know, for some people, it conjures up these images of super intelligent robots right out of science fiction. For others, it seems like almost any kind of data processing gets slapped with the AI label. So what are we really talking about? That's the big question we're digging into in this explainer.
And here's the thing. You're already interacting with it every single day. Think about self-driving cars. They have to see obstacles and figure out where to go. Or how about when Spotify or Netflix just knows the perfect next song or movie for you? Even when your phone automatically tags your friends and photos. Yep, that's a form of AI at work. It's not just sci-fi anymore. It's really a part of our lives.
Okay, but if it's all around us, why is it so hard to define? This brings us to what we could call the definition dilemma. Let's break down exactly why this term is so slippery.
Believe it or not, the confusion starts right at the top. Even the experts, the AI researchers themselves, don't have one single official definition they all agree on. The field is just moving so fast that what's considered mind-blowing AI today might just be seen as regular old computer science tomorrow.
There's this great joke in the field that really nails it. AI is simply cool things that computers can't do, yet. And just think about that for a second. The moment we figure out how to make a computer do something amazing, it kind of stops feeling like AI. It just becomes a normal computer program. The goalposts are always moving.
And then, of course, you've got the Hollywood effect. For decades, sci-fi has fed us these really powerful images of AI, from friendly robot sidekicks to, sinister machines trying to take over the world. And while those stories are amazing, they've set up these expectations that are way more metaphor than reality, which makes it even harder to see what today's AI actually is.
And this leads us to a really fascinating and crucial idea, the human-AI paradox. To really get AI, you have to understand this weird twist. What feels simple to us can be incredibly hard for a machine, and what seems super difficult for us can be surprisingly easy for a machine.
So for example, take a simple action like picking up a coffee cup. You just do it. You don't even think about it. But for a robot, wow, that involves complex vision, calculating a path, controlling muscles with just the right amount of force. It's a huge challenge. Our effortless ability to navigate the physical world is built on millions of years of evolution.
Now let's flip that on its head. Playing chess at a grandmaster level, that seems like the peak of human brain power, right? But for a computer, it's just a game of rules and massive computation. It can calculate billions of moves in a flash. And here's the paradox in a nutshell. For a computer, beating a world champion at chess is actually an easier problem to solve than simply picking up the physical chess pieces. Wild, right? Okay, so if the old definitions are so tricky, how should we be thinking about AI? Let's get to a much more useful way to define it. We can really boil it down to two core properties that are a lot more helpful.
The first one is autonomy. This is basically the ability to do things without a human holding its hand every step of the way. Think of a Mars rover navigating the rocky terrain all on its own. It gets a goal, like go over there, but it has to figure out the how all by itself.
And the second property is adaptivity. Now this is the real magic ingredient. It's the ability to get better over time by learning from experience and data. Your spam filter does this. It learns what junk mail looks like based on what you mark as spam. It adapts. So a system that has a high degree of AI-ness has both autonomy and adaptivity.
All right, so now that we have a solid way to think about AI, let's look at how to talk about it like you really know your stuff. Getting the language right is so key to understanding the tech and not falling for all the hype.
The AI pioneer Marvin Minsky had this brilliant term for this, suitcase words. These are words like learning or understanding that are just packed with all these different human meanings. So when we say a machine understands a photo, we probably just mean it can correctly identify a cat in it. But that word understand brings along all this other baggage, suggesting a deep comprehension that the machine just doesn't have.
And this leads to another really important idea. AI isn't an on or off switch. It's more of a spectrum. So instead of asking, is this AI, it's way more useful to think in terms of its AI-ness. Some systems might just have a pinch of AI, like a recipe with a little bit of salt, while others are built on it completely. It's almost never a black and white thing. And finally, here's a pro tip. Try to avoid saying things like an AI or two AIs. AI is a field of study, a scientific discipline, just like biology or physics. You wouldn't say a biology, would you? So instead of Google built an AI, you could say Google developed an AI method. It's a small change, but it shows a much deeper grasp of the topic.
So all this leaves us here. We tend to think of intelligence as this single scale, kind of like temperature. You're either hotter or colder, smarter or dumber. But as we've just seen, AI doesn't work that way at all. A chess program isn't smarter than a self-driving car. Their skills are just completely different. So here's the final question to leave you with. If intelligence isn't one single ladder that we're all climbing, how should we really be measuring the progress of AI?